Okay, well, Twitch is complaining to me that my bitrate's too high, but I will leave it for now and see if it sorts itself out. Um, Gotta use big bits to show this beautiful Mandelbrot. Um, so let us begin what we are working on. So we've actually got this drawing on the screen. It's pretty nice. I think the first thing we want to do now is start zooming, start allowing zoom. To do that, I need to actually fix this stupid thing I got stuck on last night, which was um, somehow I had some brain issue where I couldn't remember how to uh, basically set this up correctly. Um, it's really not that complicated, to be honest. So um, basically, we have the aspect ratio we want to contain set. We're going to get rid of this delta part and just move it outside because we need to use this delta for setting the center point after. So first, for now, I'll just leave it here. But so we basically just wanted to scale up the default set a little bit. I didn't need to do any of this nonsense. Honestly, like the default, if we just set the default values and then multiply them by like 2, it kind of works out. So uh, so the default was originally we had 2.47. I'm going to delete these comments, but 2.47 and 3, or sorry, 2, 2 point, what was this, 2.24, which isn't quite square, but that's okay. And what we'll do is I just basically want to scale these both to get to like 3 and 3.5. So 3.5 over 2.47, and that's not right. Sorry. Back to this nonsense. Okay, I'm just gonna scale these by 2. That's fine. And then what we will do is take this. And what I will do is do e times scale plus delta. This gets us, it gets us a syntax error. That's nice. What is the syntax error? Why is this a syntax error? Is this really going to be a problem? What is this complaining about? Leave everything I'm doing here should be allowed. No. No idea why this is mad at me. Not using this parameter. Weird. What on earth is that complaining about? Um, Honestly, most of this is like kind of irrelevant, but let us move this delta out of here. I need to do that based on the mouse position in a second. Now, I just delete that function altogether because it's not that useful to begin with, but okay, so well, honestly, well, whatever. You know what? That's fine. We'll just leave that for now. We need to get the you want to set the scroll based on the mouse scroll wheel. So first things to do is to go into here and set a scroll callback function up. So the scroll callback, as far as I'm aware, I will copy this as a starting point. The scroll callback gets the window. I'm going to use double. I'm going to use, for some reason, it gives you like a double back. So float 64. Is that code I just copied? So key callback, scroll callback, double x offset, or like x scroll. Said I don't want to use double. And F64 y. x delta, y delta. And then we are going to do some annoyingness for now. We are going to do an fprintf. Scroll x off equals x %f, y equals %f. And I did something dumb, which is I used fprintf instead of printf. Yeah, it doesn't matter, to be honest. Let's use printf. Don't care about specifying where it's going. Scroll callback. I need to call this variable the correct thing. Okay. So now if we go ahead and we scroll on the window, I don't have horizontal scroll, but we get some values. So basically it's always 1 in y or x, in y anyways. Based on this, we need to set some sort of value that is going to be related to the zoom position. So probably we'll add another uniform for that. So I will just do this uniform I32 zoom. All right, let's do it up here. Use zoom. Okay, and then in the main thing here, already I probably want to maybe break this up into a validate uniforms function, so I don't have to keep retyping this. What am I doing? I am pressing many keys. I32. Validate uniforms. Now it's going to be void. I don't care that much about fixing that. And then we're going to take this code and uh, what should I do with this one? I don't want to. Oh. I don't know if I'm even gonna act based on this, but for now, we'll just say that's what's gonna happen here. I take this, put it here. Ultimately, this was wrong anyways, so um hello Sorav. And then well, we don't really need to set the zoom. We don't really need to set the zoom every time. Well, you know, I don't know if we need to. We don't really need to set the zoom every time through the loop. Um, so oh, this uniform 1F, I think is what that one's called. Just look up the uniform code again. GL uniform 1F is how you set a single float value. So do use zoom and GL context dot zoom. So need to add a variable to that for now. And then in the scroll callback, what we will do is we need to basically, I think we'll just do and we will probably just scale in the program. And then we need to do clamping. I don't have a macro for this, and I don't really need a macro for this right now. So if y delta is less than 0, really is less than 1. Y delta, sorry, not y, I don't care about y delta. If this is less than, if this is less than 1, this needs to be not y delta again. This needs to be set to, and this like work. Okay, this needs to be set to 1, and if it is greater than, well, no, it doesn't matter. Anything less than that is fine, or anything greater than that is going to be fine for what we're doing. So now we will also go ahead and add this code and set the uniform. Okay. I should really be checking if this is 1, -1, but man. So that is it for the main, and then we will add this to the fragment shader. So we have a new uniform, zoom, uzoom, float, uzoom. Oh, I guess you can actually set like defaults for these, which I didn't realize. So you can do that. So if it's not set, then it will be set to 1. And then here, we need to divide this by uzoom, leave. So we need to close this and build the new one. Then do this. Oops. It's a little weird. I don't know what happened there. What happened to our zoom float? That's a good question. So, well, one thing I can do to figure out what is going on here is to first of all, I don't know. We can kind of set these on every loop. It doesn't really matter. Actually, both of them, like, it's totally fine to do this. So and then yes, I don't really care that much about doing this here anymore. Where is this printing going on? So here, I'm gonna add another little bit here called the zoom. Okay, so what are we getting here? Also, that is a bit annoying. So I need to fetch this so that it clears that off. That is fine for me. Okay, so the zoom should not be 0, but we will set it to something. So now we have a zoom. The zoom, I don't know about setting this like this, to be honest. That's probably the problem, is the delta. Yeah, I don't know about this delta. I don't know where to do this delta. I kind of think it needs to be in here as well. is the delta needs to be scaled appropriately as well. So so scale divided by u zoom, delta, not this thing anymore. So minus scale dot x over 2, possibly, and then oops. The color is still there, it's just the delta is not correct. So I need this to appear in the middle of the screen. So yeah, as you can see, the zoom is working, not as intended yet, but it is there. It's just the delta is all incorrect. So right, this part is definitely not correct. So basically the delta needs to make sure that this, whatever we're doing is, there we go. That's a bit better. Now I want to be able to set the position of the zoom as well. And also if we keep, yeah, because if we keep zooming in, we'll zoom in on like the wrong part of the, and also I should add like a modifier so we can like speed up and slow down the zooming. Maybe we don't want to do like that full step every time. But that is getting somewhere. What we probably want to do, so this is going to force it to be fixed at this center point right now, which we don't want. Like we can zoom here and then just yeah, I don't know if this is like going to be too useful without me just doing what I want to do, which is to set the position based on the mouse position. So we set the zoom position based on the mouse position. If we delete this, though, what happens? This is like going to be wrong, right? That's like slightly shifted. I think we always just need to, because this is like, well, we will see actually. I want to say that, but I think we should just keep this for now, and we will see what happens as I add the mouse position. So to add the mouse position, I have to go back to here, and I need to check because I haven't actually used the mouse position in another program yet. So we need to go to, don't know what is happening with this. So we need to go to the GLFW reference and just check the most input. So we need to get cursor position callback. So we need to set that one up. So cursor position, let's also zoom in a little bit so we're not just looking at that same one, same thing. So we want to do a where are we here? Okay, callback. ULFW set cursor position cursor pause callback. Cursor callback. And the cursor callback is the same thing as the scroll callback. Basically, it gets the same sort of stuff. So, except now it's positions instead of deltas. And then, I'm not going to have this here. We're going to just check how this looks. Because this also needs to be scaled to screen space. So I don't know if it is or not. And this needs to be called cursor. Cursor x equals %f, y equals %f. Close this, rebuild, rerun. I don't know what I broke. Okay, I need to fix. I do know what I broke. Okay, so this is gonna constantly just give me. Looks like in. This might end up flipped, but okay, that's fine. It gives me the pixel position. So that is good to know. Let us just try setting this default value again quickly. Just make sure that this actually works. It doesn't. I think it's because I set it to 0 afterwards. So I should set that in here when I'm setting up the thing. GL context.zoom should just equal 1 by default. And then cursor callback. So we are going to do something different here. We're going to do this again. Except we are going to add screen dimension u position. And those are two integers. So we will just do this struct u32 x y cursor. And then I think I want the cursor to be actually, I don't think that matters. Don't think that matters. So we need to go ahead and do, why are these, also I'm not sure why these are floats when the cursor position is in pixels, but that is what they give you. So we need to do dot cursor dot x plus equals, or not just equals x position. Oh, and also this is a problem. So I don't want it to like move around when you are mousing over it. Um, let's just get this up on the screen again quickly. What is going on? Who knows? Okay, so yeah, we don't want this to like move around when the mouse is just moving, so um, we have to do this a little differently. Um, maybe when you're maybe when you do a mouse click, you take the cursor position. Is there like a different is there a different callback for like when the mouse clicks? No. So there's a callback that's mouse button input, but it doesn't give you the screen position. So maybe instead though, um, there's likely a position, there's likely a way of querying the position. So maybe I should use that instead. Yeah, there's like glfw get cursor position. So maybe instead of setting the cursor callback, we should set the, well, I'm going to still call it cursor callback, but it's going to be, well, cursor callback, cursor click callback. Let's just call it mouse button callback is more clear. So we're going to take a mouse button callback instead of this position callback, which is this is closer to the other one. So it is going to take a button, an action, and some mods. Now, I don't really know what the modifiers are for this one, but what we will do is if button is equal to glfw mouse button right left and the action equals press, we will set the position using F64 X position, Y position, glfw get cursor position, I think it's called. Get cursor position. gl context dot. I might do some work to stop having this global, but we'll for now it's fine. Dot window and then add x position, y and y position. And obviously these just need to be cast. It's C, so I don't really care about typing the cast. Now when you click, it will set the center point. That. Now there's two ways of doing this. Either it just directly, so, okay, well, it has to be scaled in the, it's gonna have to be scaled, but that's okay. So I mean, we have the width and the height, so I could just scale it right here so that it is between um, 0 and 1, and then just make it a vector. And then yeah, maybe I should just do that instead. So yeah, maybe that is actually better, is if instead of storing these like this, we do this. And then we go ahead and do divided by GL context dot width. And we're gonna shift these. Um, so now this is gonna be nice and centered. Then we need to open the fragment shader and add a second vec2 uniform. And we're gonna call this one position. And in here, we need to have, we've got a U position already. Validate uniform. I don't really care about checking this right now, to be honest. I'll just let GL, OpenGL spew errors if there's a mistake. That seems more useful anyways, to be honest. So, okay, so uniform to FV U position. Cursor. Okay, so that is that. We're not using it yet, so if I don't use it, this is gonna already spew errors. So we need to, in here, what I will do is, I need to fix some of these functions because I don't like this intermingling right now, but um, okay, so close this. My bad. Cursor callback is mouse button callback. Oh, oops, I need to pass a count to that. This is not called this. This is the mouse, what's it called? Mouse button callback. What did I call my, I did just call it mouse button callback. So set mouse button callback. And then down here, I need one. and scroll callback. I don't really need to do this here. And window size callback. I don't need to do this in here either. So we need to maybe, so right now this U position exists between 0 and 1. Or sorry, -1 and 1. Um, by default, it should be just zeroed, but we need it to also get scaled by the zoom for 1. I don't know if that's the only problem, but I can see it's moving around, but we need to actually make sure this gets put to the correct position. So maybe I'm not going to be too smart here, and we are just going to do so to help me see what's going on, we'll do this, and we'll set the position. It does like move the position. I'm not sure I like how it's moving the position, but um so maybe it's better to pass these in screen coordinates. I'm not sure. Um, if we pass these in screen coordinates, what do we get? Let me think here. So do we want to pass these in screen coordinates instead? It might be better. Like, so basically we get some screen coordinates. We need the actual position um, related to, so it's actually related to this map Mandelbrot function, which I'm going to move down to the main because it's a bit more readable down here. I think, let us just try this. So basically, yeah, let us do it this way. Well, no, never mind. So this, what's happening here? So we have this in 0 to 1 space. Okay, so if that is in 0 to 1 space, then this should be 0 to 1 space as well. First of all, we should do that. Yeah, this is wrong. So and it needs to stay as a vec2 anyways. In main, mouse button callback. we still just want this to be in 0 to 1 space like the other one. Okay, so that would put that in 0 to 1 space. And then we want to what do we want to do here? So it's basically going to serve as like a delta. Just not in this way. Actually, this might actually fix it partially. I'd like to be able to drag as well at some point, but for now we'll just start with this. What do we want to do here? So um okay, so sorry. So the screen coordinate, we don't need this open right now. The screen coordinates, they come in 0 to 1 space. Just like the this value here is also 0 to 1 space. So we want to use that to shift the position. Now the default position needs to also still be taken into account somehow. How is this gonna work? So um let's just try some things. That's not like actually how I intended for this to work. So what I actually wanted was for What I actually wanted was based on this current coordinate space. So we have to actually keep track of the coordinate space on the main CPU now, because if we do not do that, um, then when we click, it is going to jump all over the place because this is just some, yeah, right. So actually, we kind of need this Mandelbrot function to be done on the CPU first, and then also possibly on the GPU. But we need to do it on the CPU so that we can figure out where the um, precisely where the cursor is currently positioned. Now this could also be converted probably to just like a um, what's it called? Like a just a matrix equation, which is maybe a little better. Let me think. So, well, I need to go to the washroom, so I'll do that first. So, yeah, so when we start zooming, what is it that we actually want? We want that we need to use the mouse position somehow when we're zooming. So, um, if we get the mouse position and then we map it to this space, what we can do is set the there's two things we have to do. The delta needs to be modified, and the like we basically need to start moving towards, I think, somehow. Hmm. So yeah, so when we're doing the zooming, we can take into account the mouse position, and then the mouse position should become the center position. Probably over a few frames, we want to move that towards this. Oh no, the mouse. Yeah, so the mouse position is going to be the center position of the scrolling of the. Let me think. So when we start zooming, um, the mouse position should get recorded. Um, So every time we do a zoom step, the mouse position should be recorded. And it needs to always be on the screen somehow. This is a little difficult for me since I don't program. I'm not an expert at graphics programming, so that's why this is a little fun, but it's also very difficult for me to think about. Um, Let me think. So we have the mouse callback. I don't know if I like the mouse callback right now. Also, I think I'm gonna add that actually right now. I'm gonna have a right click to just reset everything. Because that is gonna help me a little bit. So, right. And we're just gonna set these to 0 when that happens. Think. Yeah, because like definitely this thing does not work how I would like it to work yet. Also, it'd probably be helpful to be able to just use like WASD to just pan around a little bit. So that'll actually help me a little bit here as well. So I think what we'll do before we just do too much more work with the mouse is we will actually add the what's it called? Like the key bindings to just do that. So I'm gonna switch this to a switch on the key. So case. There's some other ways of doing this, which I might do, but for now this will be fine. If this is the case, we do this, and then we break. If happen there, if action equals this, break. This. Then case glfw key w asd asd. If action equals glfw press or action equals glfw repeat. I'm gonna, yeah, I kind of want to fix, I kind of want to get rid of this global variable, but cursor.y plus equals, I don't know, 0. You have to keep in mind we're in the screen space, so something like this probably. So for A, it's going to be x, it's going to be minus equals. For S, it will be y, it will be minus equals, and for D, it will be x, and it will minus equals. Then, what was this? So if we zoom in now, it's a bit slow. Maybe 0.5 is better. Also, I can add like shift, so I can actually check the modifier, and if it's like shift, we set the scale to something. Um, okay, so that's a little better. Now we can go ahead and scroll this to somewhere interesting. The math is all completely wrong, but that's fine. Zoom in, zoom in, zoom in, zoom in, zoom in. So I'd also like this to be, so right now it's like not smooth scrolling. I'd like it to be smooth scrolling as well, so I can do that. Do that. Um, well, to do that, we have to set like a target and then move towards kind of deal on every frame based on delta t. And it needs to have like some amount of acceleration, so it's not like super slow, but it'll look smoother then. Also, I should probably um, add some checkpoints to the code here, but whatever, fine. So yeah, that's nice. That is nice. Um, so let us what do I want to do here? So I want to so this will also reset that, and it doesn't reset the zoom, which it probably should. Otherwise, we're going to run into issues. So should we do here? So I want to, I kind of want to set these things to speed up based on if shift is pressed, to be honest, 'cause it's a little annoying right now. And also we need to fix this to also potentially reset the zoom. I kind of think that's a good idea. not 0, 1. Okay, so in the zoom thing, F32 scale equals, um, what is the, I think it's GLFW get, um, key, what is the, there's like a key function. Is it like get, uh, yeah, I have the code in one of my other projects. I'll just check that one. Scroll. Yeah, so it's just get key is what I just want here. So GLFW get key, um, win, uh, GLFW left shift for now, be both of them. Um, so if that is set, the scale should be, I don't know, 10, else it should just be 1. Just put this here. Not there. Where are we here? What's going on? Hello? Okay. Um, here. And then same thing up here. Except in this case, I think the modifier should tell us this. So I might not need to do this. Not the modifier, yeah, maybe the modifier. Um, maybe not. Oops. Mod if I modifier bits. Yeah, so there is. It's GLF. Okay, so float here should just be mod and GLFW mod shift. We're using that one now. And then what we do is 10 is probably too much for this, like maybe 3 or 4. And all of these should be multiplied by scale. I still would like to do like the smooth scrolling, but we will get to that after. So now we zoom. 10 might be a little excessive. Maybe not. Okay, it kind of depends on like where you are. So now, anyways, we can at least scroll faster. This is kind of a cool. I mean, we're kind of like running out of some. There's an issue here that is going to start showing up, but that's okay. That is pretty interesting looking. Um, way zoomed in now. Maybe I should also be printing the cursor to help me with debugging. Um, yeah, let us do that, I think. So if we go back to here, and this string is getting long, but so I'll just split it up. Um, first, let us actually just call the zoom. We'll just call the zoom the Z part of the cursor. Um, equals send to F. Um, so we want, yeah, let's just do percent to F. Actually, so the zoom just needs like the one, and then the these ones probably need more precision, to be honest, like, or at least, I don't know, probably. And then GGL context dot cursor dot x GGL context cursor dot y. Okay, so that is looking good. Now if we do this and we go somewhere else this time, over here, do one of these things, I think. And I should, what's going on here? Okay, like that. So I think what I'm going to find is that, first of all, the cursor is the cursor be like that? I'm not actually sure. Might not be setting the cursor correctly. Oops. Oh, right. Oh, right. Okay. Anyways. Um, I need to set the zoom down. It's too high. Zoom zoom scale is too high. Let's go with F5. Um, I'm not gonna recompile that just yet, but so um right. Let's take a look. So next, what do we do? What do we do? What do I do? I'm gonna stream some more, but I need to. I think I'm gonna make some more coffee. Is what I'm gonna do quickly. I'll just go and put some water on. Yeah. Okay, so what I'm gonna do first is so the scrolling, the mouse clicking is dumb. I don't want to do it. I don't like how it's being done. So um start with let us so instead of doing this, what I want to do is um calculate a delta, and it's going to be scaled. So with a 32 delta x is equal to x position over this. It's going to be 2 times this minus 1, so it's centered, so that so we want to move in based on where you're clicking. I want to move. Delta y is going to be like this. And then there's going to be a scale related to the zoom somehow. I'm not sure exactly what that is going to be. So I don't think we should just multiply by the zoom, but it's possible. I will try that first. This is dumb. Scale equals this. So what we're gonna do is um, plus equals scale times delta x y. Oops, I should have done that first. Okay. So let us try this. Except not in this way. So that is wrong. I want this to be flipped over. Flip over y, not. I think x is no. Both of them need to be flipped. I don't like that. So let's try this again. Then we have to zoom in and see if it's gonna work better. So yeah, we can't just scale it by the zoom. Um, because that goes like yeah. Maybe the scale, it doesn't need to be scaled. Let's try that. So if we zoom like way in, does this makes also don't quite think it's moving how I want it to move. Like I want it to okay, it is moving how I'm telling it to move, but um still not like happy with the way this is coming out. Um Roll up to one of these ones. I'm also still not quite happy with the color. I don't like how it's like missing all the greens. So you can try that. So we don't really I don't know if I should start with the okay, let us just make a checkpoint here though. Because this is like getting rather long. That's not that long. but we will do this. Oh, and I've also been compiling without. That's funny. I've been compiling it in like without optimizations on it. It's still just yeah, 60 FPS. So that's kind of expected, but um, we'll turn those back on. So we're not wasting compute just doing useless. And then we will figure out the better way of doing the zoom because I want the zoom. Basically, the way you want the zoom is based on the mouse position. You want to zoom in on that region specifically. Now, to do that, you need a few things, right? You need some positions and you need some, yeah. Basically, you definitely need some positions and stuff. So, oh, and also one thing I forgot to mention, and I can show that now, is just um, so this Mandelbrot escape calculation basically means that this color is like somewhat independent of the number of iterations you do. So if we like lower this update, there's like I don't even know if you can see like there's no visible difference. If you go like really low, this is the other thing. So I'm pretty sure this is like a graphics driver bug. Um, so when I was trying to set this to 128, it's just gonna crash. I'll show that in a second. But if you set it to something lower than 128 or higher than like around there, it doesn't crash. So yeah, if you do this, we lose a lot of the details because we're not going for high enough to get the detail. If I go to 128, it will crash. Don't ask me why. Then if I go back to like 200, maybe it will not crash. Oops, I need to build it. I just need to run it. Yeah, if we go back to 200, it does not crash. Do not ask me. I have no idea. So we will scroll somewhere interesting and zoom. Fractals are awesome. I love fractals. Just look at this. What is going on here? I have no idea. No one does. Just some very like look at the math that's generating this. It's like it's nothing. There's nothing here. We're taking x and y squared and we're adding them together as complex numbers, and then that's it. That's all that's going on, and this is what we get. Yeah, so this clicking is wrong, but if we increase this now, it'll get a little bit more color. Um, yeah. Anyways, and you can also like it should also be like mostly independent of this thing. Well, not one, but yeah. So there's like a few. You miss like you lose like a few of the little smaller ones if you shrink this. It's related to like the error term. Um, anyways, oh also to really improve the error term, what you can do is um, you can force this to always run a couple extra iterations. Let us do that quickly and just ignore that part. So we will just run 2 extra iterations. Oops. Well, yeah, to show that in the comments. Well, I guess you guys probably saw it. I wasn't looking. So yeah, if you do that and then you just add a couple extra iterations, can like improve the it improves like the distribution a little bit. So um, I don't know like how much it matters. Like if you do like four, yeah. Um, so I don't know. Two is fine. Let's do two extra iterations. Um, to reduce error in escape calculation. So, all right, so let us commit this as a start. So we have a checkpoint. I think everything here is good to go. This map Mandelbrot is still like kind of messed up, but we'll fix that in a second or later. Um, good. Care about that. That's all good. Um, don't want to uh, do this. That is good. Good. So git commit. Add basic scrolling and or basic zooming and panning. Okay. So now we have a nice checkpoint to get back to fairly easily. Um, so I'm thinking I want to add like the smooth or scrolling. I'm not sure. Maybe not. Maybe I should fix the zooming issue first before I add smooth scrolling and nonsense like that. Um, so I think to do the zooming correctly without it moving around like this when I zoom, what we need to do is um, what we need to do is I need to know what the position is of the mouse cursor. So the mouse cursor um, so you want to calculate the mouse cursor in screen space and then make sure that the other values get adjusted such that the cursor does not move or that position does not move. Um, which to do that, I think we need to add this map Mandelbrot function into the C code as well. So um and I might just start adding some vector types to help me along with doing that. So we're gonna have a v2 just go up here and do that right now. Type def rock the F32 XY E2. Oops, let's check what is going on. So we have XY position. Then with XY position, what are we going to do? So we are going to this map Mandelbrot thing is kind of wrong, but well, it needs to be written correctly, and it should just be duplicated here between the C code and the other codes. So start by doing it this way. So what we do is we take a vector2 in that is the normalized screen coordinates. So screen position, which should be normalized. So I haven't done this yet, but I kind of am thinking I want to have an assert macro to help me along here. So where do I want to put these macros? Probably after the types. So we're just going to do this. This can be disabled, but assert condition if not conditioned. So I'm using Clang. Don't know, maybe I should just use the inline assembly and not use Clangs built in for this. ASM int3 no op is fine usually. Well, I think the Clang thing is more readable, so I will use the Clang thing, even though the Clang thing is only a Clang thing. What is the thing? It's like built in something or other. It is built-in debug trap, and actually, okay. So let us do this. If def Clang find assert built-in debug trap else and if find assert ASM int3 no op achieves the same result, however, well, this mattered. So basically what happens here is if the assert fails, the program will crash, but if you're running in a debug, the program, if you're running in a debugger, it's equivalent to like setting a breakpoint at that line, and then you can continue. You can modify the memory and then continue after it. So this is like a useful macro. Sometimes you want to like disable these checks. If you're like, you know, if you have a ton of asserts everywhere, it can be like slow, so you might want to disable it. I can add that after. Right now, it's totally fine to just leave it as is. So what do we want to do? So, okay, so map Mandelbrot, that is down here somewhere. Is that a ton of... We want to assert that screen position this is also going to be another useful macro to just have is find between x low high. So x is greater than or equal to low, and x is less than or equal to high. Probably just wrap this whole thing in this. So there we go. So that's a good macro. Assert that between position x, 0, -1, and 1, like f, whatever, and between screen position dot y -1, 1. Okay. So that is helpful. Now, okay, so now we know that that is correct when it gets here. And then let us open the fragment shader as well. So Mandelbrot. Probably we want to make this a variable. There's actually like a little bit of a weird thing here where the default position for the Mandelbrot and the default, yeah, we might want to like save this default position. Let me think about this. So probably we want to store the default position, maybe just in this function directly. So it's going to be the default. Should I add like a rectangle? That might actually make this code a little clearer. Not cleaner. I don't like clean code. Clean code can die. So here, so we want to do a v2 default. I don't know if this belongs here. We kind of want to have a rectangle here that's like the bounds. Because if we have if we use like a rectangle, then we can just like it's gonna make like the code a lot clearer if I do that, I think. So let's try that. Let us make a rectangle thing as well. So v2 top left bottom right, maybe. and it's going to be a rect. The map Mandelbrot will take the screen position that we want. It'll take a screen position and it will take a rect. Bounds. So this maybe can get renamed. So maybe map Mandelbrot's not a good name. We want to do map screen to rect. Something like that, I don't know. So once we know that the screen position is in the boundaries, or is in this thing, we will calculate some values here. So we need the flow32, actually back to center position. This is going to be equal to dot x is equal to bounds dot top. This is going to be ugly, so I need to put some multiple lines. Bounds dot top left minus bounds dot bottom. This needs to be divided by 2. Bottom right dot x. Sorry, this should have both all been dot x. Divided by 2. Then y. So we have a center point in the rectangle that our target rectangle. With the target rectangle, think now all we have to do to map the screen position to this rectangle is to take the okay, is to take these positions and right, so this is in the middle of the rectangle. So if we multiply the middle by... Okay, so let me just work this out because I should really have like a drawing thing open or something so I could just draw this out. When it comes to shapes and stuff, I do much better with the visuals. So we have a center position. So let's say the center, so let's say our boundary is x is ranging from -2 to 2. Well, let's do this way so that it's not yeah. Okay. Let's do 0 to 2 so that the middle point is 1. And y is from 0 to 2 as well, so the middle point is 1. So if we have the center point, our screen position is -1 to 1. So we have to take the middle point and add, if we take the screen position times the middle point and add it to the upper boundary, then that should work. Does that work in all cases? So if this was -2 and 0, then if we take this and we add it to the upper boundary, yes. No, it doesn't. Because if we were at -1, -1, yeah, this is dumb. Like the screen position should just come in a 0 to 1, 0 to 1, um, kind of deal, and then this all just is way easier because so if it is 0 and we add, so if the lower bound is 0, we add multiply the center point by that and add it to here. If it's 1, we multiply the center point by what? Brain. Brain, please help me. Help me. Okay. Yes. Size is equal to need this. This is what I need. So this needed to be that, not the other one. I don't think I even need the center. I don't know why I had the center in my brain. So, okay, so the size, and then if this is 0 to 1, all we do is multiply by the size and then add to this the lower bound. Yeah, so we return v2 dot x is equal to size dot x times, okay, actually, yeah, this is going to go on a different line. So dot x is equal to bounds dot top left plus size dot x times screen position dot x. And dot y is equal to the bottom corner, I believe. And then okay, so the boundary is gonna, the center point of the boundary is gonna be set by the cursor position, I think, is what I want. So the center point of the boundary is set by the cursor position, and then right, so let me think about this. So the center point of the rectangle is set by the cursor position, and then the uh Yeah, and then the zoom is going to be related to the size of the rectangle, but the zoom doesn't come into play. Also, it's possible I don't need to send the zoom to the. Possible I can just send these boundaries to the GPU instead and just use those for mapping, and it will be a bit clearer about what's going on. Um, I think it will actually be clearer about what's going on if I do that. I'm gonna go to the washroom. So the rectangle, right? So what do we have here? We have a rectangle. Um, this rectangle, we want to store a rectangle as a viewport, so we need to have another function here. So the cursor, um, we're actually not going to store this. The cursor is not going to be a cursor anymore. I'm going to store the boundary of the screen, the screen boundary. So it'll actually be made up of two vectors. Um, and that screen boundary is going to be in uh, it's going to be in GL space. I think is the best way to do it. Yeah. So that screen boundary is going to be in GL space. So -1 to 1. Um, there's this weird thing down here. So we're not going to store this anymore. We're going to store a rectangle, a boundary. The rectangle boundary. And then what we're going to do is I'm going to need a function that is going to move that boundary. So we're going to do a function here. Kind of don't, well, okay, it's fine. Who cares? um, static rect, move rect. So rect is going to take a rect r and a v2 delta, and it is going to return a vector, a rectangle that has been moved by that delta, and we're going to use that to scroll the scroll this boundary around when we're pressing keys. So this is going to take a so r dot bottom that dot top left plus equals delta dot x plus equals delta dot x, delta dot y, and then bottom right. And then we're going to return r. Okay. So that is good. We should set the default boundary here to be boundary is equal to rect I don't know if I'm allowed to do this. Let's see. Yeah, so it's gonna be like what I was doing before. So I had this what were the positions before? We had 3.5 minus 0.765, I think. No, so sorry. What is even going on here? So yeah, so to start with, we had this okay, so we had 3.5 and then we were shifting it over by it was minus 0.765 shifted over by minus 3.5 over 2. So it was this. This is not GL coordinate space though. Oh, duh, yeah, of course this can't be in GL. This of course, this cannot be in GL coordinate space. The boundary is not, it needs to be mapped to, well, yeah, it needs to be mapped into that. So, wait, hello? That doesn't make any sense. So the boundary is not in, yeah, that doesn't make sense. The boundary just has to be in actual number space, not in GL coordinate space. And then we have to map the GL coordinate vector into that boundary. So it's just in the normal. There's nothing weird about this one. It's just literally yeah, and this was gonna be 1.5. Yeah. Okay. And then I don't know if this is even allowed in C, but we are about to find out. I can't remember, to be honest. And then this should go to to 0.23. That's not right. Um, yeah, this isn't right because right. Uh, it needs to contain 0.247 to 0.47, but I scaled it up a little bit more. So what is actually the, I wanted to go from, I think I need to look at what that comment was that I deleted, to be honest. Let's just do this. So yeah, what did I have here? I had minus 2.5 to 1. And I had y going from this to minus, okay, something like this is what I had before. Um, put this like somewhere here. So we had okay, so this rectangle is correct now. Um, the zoom in, does the zoom in even matter? I mean, the zoom can still, I mean, if we divide this boundary length by the zoom, yeah, I mean, the zoom is kind of, I don't know. We will see about the zoom. Um, so uh, what am I thinking of here? We want to set this, and then, okay, so we've got the boundary here, and then we want to move the boundary in the, when we're pressing the keys, and we have to send the boundary as well. So let us send the boundary first. So back, I think you can do this. Or you have to use a block. I think this is allowed. Not going to be any position anymore. So this function is going to do the same thing as this other function I just wrote up here, where we've got the size is equal to top left minus bottom right. And then I think we can divide that by the scale, by the zoom. Now we're going to get rid of all this weird delta stuff. And so we have our size, and then we want to do so vec2, let's just do this way. Vec2 L equals vec, whatever. L dot x is equal to top left dot x plus the size, yeah, plus v dot x times size dot x. And dot y is going to be equal to the bottom right y, v dot y, size dot y. And then we're going to return out. Okay? And then there's that. Then we have to actually send this to the screen. So okay, and then here we have 4FV boundary 1. This struct should be fine to just pass along. I think. But it might not be. We will see. Okay, so that is that one. Check if this alt still works. This is obviously not going to work because, well, first of all, because it's complaining about a syntax error again. Unexpected out token expecting blah blah blah. 61. 7. I was more expecting it to complain about stuff being missing. I'm not actually sure how to do this, so I'm gonna just, for now, I'll figure this out after. I don't know if this is what the problem is, but no, it doesn't look like that's the problem. Why does that want to complain? Is it because I need to like do this? No. Don't think so. V dot x, v dot y, dot bot, right? Scale x, scale y. First of all, Okay, that is a bit better. I don't know why that was an error, but it was. So, um, yeah, that is fine. Um, let us close this, and then um, well, yeah, we will just disable all this for now and fix this after. Where else do we got cursor? In the mouse position and in this thing. And in 350. Right. Just gonna disable this for the time being. And we will fix that in a second. I want to make sure that this still displays something reasonable. Um, okay, so let us do. Yeah, I need to check how to do the struct thing because I might be doing this wrong. So I'm a little worried that that's not going to be correctly aligned. So let me just see here. That's aligned. Then there's 4 of these, and then there is 1, 2, 3, 4, and then there's 1. Sorry, there's 3 of these. Then there's 4 of these, and then there's 1 of these. So that's all aligned, and then this will be aligned on that boundary properly. So that should be okay. I might have to open the debugger just to make sure that's all looking good, but invalidate uniforms, we are going to switch this to U top left and top left and bottom right. That name's too long. I'll fix this after. Okay, so then here, instead of doing this, we're going to do GL uniform to float vector. It's going to be GL context dot U top left 1 F32 pointer and GL context boundary dot top left. And then X top left bottom right. Okay. Top left, bottom right, top, bottom right, top left. Da, da, da. Okay, so something here is not quite correct yet. let me see. So vector v comes in 0 to 1 land. Then what we do is we calculate the width and height by doing this, and then we divide it by the zoom, which is probably 1 right now. Just make sure, we'll just scroll out. So the divided by the zoom, so the scale is now the width and height proper. So now this is in the range of 0 to width and height. That's all good. And then we need to add the bottom two positions. So, oh, I guess like the problem here is that these need to be, this can be negative. This needs to be like the absolute value. Those are positive, and then we can add v. Is that right? Or am I dumb? Most likely I'm dumb. The scale. Let me just type this out like completely. So let's go up here to where we set the default boundary. So I can have a look at what I'm doing. So back to scale. So this map here, this map screen to rect is correct, but or is maybe correct. Maybe it's not correct. Maybe it needs to be absoluted because so in the case where the bottom left is negative, which it is right now, and the bottom right is positive, this still gives us the correct. This size is supposed to be absolute valued, right? So also we probably want to do this in the other direction anyways. I'm also thinking that the where's the 0 point of these position? Like possibly the 0 point is the. It depends on where you want the 0 point of this rectangle to be. Since I want this to be like width and height, it makes sense for the corner, the bottom left corner to be the 0 point. So bottom right y and then top left y. If that's the case, then you want to get the height, you want to leave this part. Yeah. So that would be that. And then let's just do this properly then. Vec to scale dot x is equal to oh, these aren't even called this. Oh, they are. Well, that is probably part of the issue then. Because this is not what I called them in here. These are not even being set correctly. Cannot construct vec2 from non. Yeah, that doesn't matter though. So I need this to be correct. So U top left, U bottom right. Oh yeah, sorry. I forgot to rename these. Okay, there we go. Okay. Duh. So, okay, so let us go back to what we were doing then. So this is correct. This calculation just needs to be corrected in this main one. So I'm going to add a little bit of a macro here called define ABS x. It is going to be x less than equal to 0 question mark minus x or x good. So then if we go back to my map, Mandelbrot thingy here, these two things need to be absoluted. And the order doesn't matter anyways, but that's fine. And then, so this, we can still zoom in, it's just not, just like even more wrong than, okay, well, that's fine. Oh, because yeah, well, that makes sense actually. Is that right? Um, I'm not sure, but, well, the zoom is kind of an issue right now, so it's possible that it's actually correct, and I need to just properly do what I'm supposed to do here. Let us adjust the boundary now. So in the key callback, we will adjust where the boundary is going. So we can shift this around. So to do this, we want to do boundary equals move rect. It's going to be this. And then v2 dot y equals this. Let's look right. I think so. Dot x equals minus dot y equals minus dot x plus. Okay. That is good. Can we pan around? Okay. So we can still pan around. Oops. Yes. Scale. Now we have to actually care about the scale because the boundary is already in screen, or the boundary is already, yeah, so the boundary needs to be adjusted by the zoom at all times. So scale, not scale. So the shift value is going to be equal to 0.05 divided by, could be scale times 0.05 divided by zoom. I think that will be correct. And then here it's going to be shift. Let's get spell. Shift. Sorry. Minus shift. Minus shift. Probably should be delta, not shift, to be honest. That makes a lot more sense. Now the only thing is maybe for the zooming, the speedy one, we might want to go a bit bigger. And maybe even the default, like maybe the default should just be, well, no. So that's good. Let us leave it like, probably we'll do that. And then, I don't know why I'm doing this. This is a little stupid. So, and 0.05. Okay, so something like that should work for that one. Now the mouse doesn't work right now. That's okay. And let us go and re-enable our printing so we can see some stuff. So here we don't have the cursor anymore, so it is going to be bounds are going to be yeah, sorry, 0.04f top left. Just do this so that it is actually a little bit more readable. top left, top that, then this. And dot zoom. Zoom. And then that can go away. Boundary dot top left dot x. Boundary dot top left dot y. Boundary dot bottom right dot x. Boundary dot bottom right dot y. Okay. Up in there, unused. Did I leave something that I shouldn't have left? 1, 2, 3, 4, 5. 1, 2, 3. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Why is it saying that's not being used? 1, 2. Why exactly is complaining that that is not being used with data argument not used by format string? What do you mean? I'm pretty sure it's being used by the format string. Also, I should probably stop soon. Let us just fix this to make sure it is working. Boundary top left dot x, boundary top left dot y, bottom right dot x, bottom right. Like miss a comma? Like what gets printed? It's garbage? Oh, yeah. That would make sense. Okay, so zoom. Okay, yeah, I missed the percent, that's why. Probably I need to print some of this on a different line though. So zoom is gonna get moved back up here. And then this is gonna get put on a new line. And this part is gonna be gone. Oops, I needed another new line. I just want to see where this is. I need to wait for a couple more. Well, it's fine. Good old standard IO line buffering. Yeah, so the zooming is becoming like really slow. I need to like fix that, but um think that is going to be pretty good for now. Let's just take a look at what else I need to just finish cleaning up quickly before I pause for now. Um yeah, so I want to figure out how to do this struct thing. I'll do that later. Um yeah, let's okay. So I'll uncomment these and we're not going to use the mouse for moving around. So I might delete that part for now. Or comment it out, and then move rect is being used, so that's good. This part is not being used yet, so I'll probably not commit that yet. And then I will take pause. So mouse button, whatever. Yeah, so here we are gonna just if zero this part out for now. And I will fix that part after. This part, we need to do ggl context dot boundary. It's going to be equal to default boundary, which I will define at the top of the program. So here, this is going to be default boundary as well. And this can come with the, oops, this part come with me up here. And I will shove that up here. Static rect default boundary equal to oops. Okay, and this doesn't need like that. There we go. So that should be good. Probably I'm gonna kill the bitrate by doing this, but that's okay. Alrighty. So that is going to be it for me for now. Now I will come back later this afternoon and I will continue working on this program. Um, this is looking pretty good though so far. We have got some giant Mandelbrot going on. So thanks everyone for watching, and I will talk to you. I will be back soon. All right, bye.